So I think some problems left here. The article 12.1. And not done. I'm audible or not? I'm audible. What happened to you
Yes,
all?
ma'am.
So some problem left, I think.
Yes, ma'am.
What is that number? Tell me the number.
Ma'am, question number 34.
34.
Yes.
Describe in words. Write down. If you want, you write down. Describe in words the region of R3. The region of R3. R3, all of you know, it is three-dimensional. Represented by equations or inequalities. Represented by equations or inequalities. Question number 34. X square plus y square plus z square is greater than 2z. You are able to describe in your own word. Able? I'm doing here. No one is replying. What happened to you? This implies I can write down here x square plus y square plus z square minus 2z then is greater than 0. Okay, that I can write down x square plus y square plus z square minus 2z plus 1. I add 1 this side, so it is also greater than 1. I add 1 here also. Okay, this implies x minus 0 whole square plus y minus 0 whole square plus z minus 1 whole square is greater than 0. Sorry, is greater than 1. So what you say this one in your language? What you say? Can anybody?
Ma'am, center is 0, 0, 1 and radius is 1.
It is written as greater than 1.
Okay.
Not written as equal to 1. Written as greater than 1, not. It represents all points outside of a circle with radius 1 and center 0, 0, 1. Write down. It represents all points, means you can choose any value for x, y, z, all points outside of a sphere here with radius radius 1 and center 0, 0, 1. Or you can say it is a sphere having the radius greater than 1. It is an equation of the sphere having the radius greater than 1. You can write down in that way. Okay. So now there is a question, it is given question number 41. I say I'll do that one. Can anybody try? Question number 41. That is given as assignment to you. Find an equation of the set of all points. Find an equation of the set of all points. This question is important, mind it. All points equidistance from the point A. It is a point, it is -1, 5, 3, and B, it is 6, 2, -2. Describe this set. Describe this set. All of you clear? How you will solve? I am audible?
Yes, ma'am.
What is the question asking? Find an equation of the set of all points. Equidistance from the points A and B. So it is your, let it be a point. Say it is the point is say X, Y, Z, name as X, Y, Z. We don't know the value. The set of all points means you have to choose value, any value for X, Y, Z. So it is the point X. Equidistance from the, say it is given as A. It is -1, 5, 3. And also equidistance from the point B. It is 6, 2, -2. So it is, say it is C. So it is, you see, it is an isosceles triangle. This side and this side both are equal. It is given. Equidistance, it is given. So what will do here?
Distance formula.
Yes, you have to find out. Then
AB.
write down these two are equal. And simplify. So what you write down here, it is root over of x plus 1 whole square. It is -1, 5, 3. Okay. X plus 1, so plus y minus 5 square plus z minus, am I correct? Am I correct?
Yes,
It is
ma'am.
correct or not?
Yes, ma'am.
Then BC is equal to x minus 6 whole square plus y minus 2 whole square plus z plus 2 whole square. Okay. So now you get, that is your x plus 1. Remove that root over. I am writing here square. So it is here x plus 1 whole square plus y minus, you simplify, whole square z minus 3 whole square is equal to x minus 6 whole square plus y minus 2 whole square plus z plus 2. You simplify, what is the result? Simplify your result.
Ma'am, 14x minus 6y minus 10z equal to 9.
Very good. After simplifying, we will get 14x minus 6y minus 10z is equal to 9. Clear? So it is over. Any doubt here in 12.1? Any doubt?
No.
I think all the assignment question after this question number 41 you can do. Now come to the 12.2. I'm going to erase.
Now wait a minute.
Sadali. ଶୋଇଥିଲା ଉଠିଲା କହିଲା ଗୋଟେ ମିନିଟ୍ ମ୍ୟାଡ଼ାମ।
मैम हो गया
Over? So okay. 12.2 is your vectors. 12.2 is your vectors. What is vector? What is vector used by scientists?
It contains both magnitude and direction.
Yes.
Direction.
Both
Quantitative.
and direction. Okay. So it is always represent like this. If V is the vector, we represent it is as arrow mark, and this arrow mark, it is the direction of the vector. Okay. And the length here from the starting point to the ending point, that is the length magnitude of the vector. Now, here, if A and B are 2 points, it is given. A is the point and B is the point, another point. Then we say AB vector. AB vector, it is written as like this. That you can say the B vector, where A is the initial point, B is the terminal point. Okay, when the two vectors are equal vector, when we say two vectors are equal, equal vector.
Direction is same. When both magnitude and direction are same.
But the positions are different. Say it is the vector u. Say it is vector u. Say it is vector v. Then we can say both have the magnitude and the direction are same. So we say it is our equal vector, that is v is equal to u vector. Okay. So zero vector. Zero vector.
Ma'am, the length is 0.
Yes.
Ma'am, a vector whose initial and terminal point coincides.
Yes. That means length is 0. If initial and terminal point coincide, you can say it is a circle. Isn't it? The length is 0. No specific direction known as zero vector. Write down the vector
Ma'am,
which
it is
is
called
length.
null vector.
Denoted by zero vector, yes.
Ma'am,
Denoted
it is called
by,
null vector.
yes. Vector which has length 0, no specific direction is known as zero vector and it is denoted by length. Okay. Now, combining vector. That also all of you know. Combining vector. Particle moves from A to B. A to B. Then it changes the direction. Move from B to C. B to C. With this displacement vector BC. Okay? So the combination effect of this displacement is the particular has A to C. What you say about that A to C?
Resultant vector.
Yes, that is your resultant vector. That is your AC is equal to AC
AB plus
vector
BC.
is equal to
AB plus C.
AB vector plus BC
Vector.
So in general, if you consider this vector as U vector, and this vector is V, general form. So then we say it is our, what do you say? It is our U plus V,
V.
E plus V, resultant vector. Is not it? So the terminal point of U and start with the initial point of V. The resultant vector is the initial point of U and the terminal point of V. Is not it? So this is called your which law? You know?
Triangle's law.
Triangle. The triangle law.
Huh?
Parallelogram law. Parallelogram law.
And same क्या खाली difference होगा?
Yes.
अब मने पढ़ने थे पाई.
मने पढ़नी नहीं. Parallel to this and parallel to this. Sorry, my figure is not correct. So it is your V vector. So it is your V vector plus E vector. Okay. So this is called your parallelogram law. Okay. Scalar multiplication. Scalar multiplication. If C is a scalar and V is a vector, the scalar multiplication, if C is a scalar and V is a vector, then the scalar multiplication of C with vector V is a vector or it is not a vector? It is a vector or not? I am asking you.
हाँ मैडम vector होता है.
It is a vector. and the length of the vector V is the
C
length of the
times
vector
vector.
V is C times
times
absolute value of C times of V, isn't it? Of V, and the direction of the vector V. The direction of the vector B depend on the value of C greater than 0 or less than 0. If C is greater than 0, then the direction of the vector B is direction of the vector B kona? It is same direction. If C is greater than 0, if C is less than 0, then it is opposite direction. C negative. Less than 0 means C negative. It is opposite. If my direction of the vector B is this way. If C is greater than 0, so it is in this direction. Positive direction. If C is less than 0, so it is in positive, negative direction. So opposite direction. Okay. And if C is equal to 0, what you get? If C is equal to 0, what you get? Hmm? D? B is equal to 0. 0 vector. C to B, it is 0. We'll get. So now, for example, if A is a vector and B is another vector, and it is shown as A is like this and it is shown as B is like this. So that draw a figure A vector minus 2B. A vector minus 2B vector. You are able to do minus multiple by C less than 0 here with the vector B. What you get this vector? Minus 2B vector is our B vector is there. So minus 2B vector is this way. It is clear? It is clear? I am audible?
Yes, ma'am.
Yes, ma'am.
So it is your, now it is minus 2B vector. We can find out from here. Opposite side C is, according to our definition, C is less than 0. So it is minus 2B. Now if you join A, now you join A is this one. So what you get our this value? What you get, it is a initial point and then terminal point. This. What you get? This one. It is A vector. What you write down? Initial and terminal. Already I told you here and here. What is this value?
A minus 2B.
Yes, very good. It is A minus 2B. This plus this. This is minus 2B. This is this plus this. So we get this value is our A minus 2B. This is our figure. A minus 2B. Now come to the component. In two-dimensional vector, how many components you have? For any point, it is how many components? For any vector?
2 component.
Yes. In three-dimensional, you have also 3 components. Now come to the component. A is a point it is your x1, then y1, z1, and B is another point, that is your x2, y2, and z2. Okay, so AB vector, what do you write down? What do you write down? AB vector
x1 x2
minus x1,
y2 minus
এটা
y.
কোথায় গেল?
y2 minus y1, then z2 minus z. So that is your component of this vector AB. Here your x component is this one, y component is this one, and z component is this. For the vector AB, you can represent as A, no problem. A vector AB, it is like this. That is recalled as the component. Having these 2 points, AB vector has the component this. Now, position vector. Position vector. A vector which is drawn from the origin, that is your origin, say it is your origin O, origin, drawn from the origin, say it is our point A, having the point it is A1, A2, A3. So my vector OA is position vector, that is the point here, it is A1 minus 0, origin means A1 minus 0, it is our A1, same A2 and A3. But you have to write down in the vector. That you can say it is your A1 I cap, A2 j cap plus A3 k cap in 3-dimensional. All of you know about the 2-dimensional. Here also we write down it is as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. You can write down in this way. Okay. For example, do it yourself. Find the vector, write down, find the vector represented by directed line segment, with initial point A, that is 2, minus 3, 4, and the terminal point B is your minus 2, 1, 1. Find vector. Find a vector. Tell me the answer. Tell me the answer quick.
Minus 4
minus 4 I cap,
3.
Yes, it is minus 4 I cap, then
plus 4j.
4j cap minus 3
4j minus 3 cap.
minus 3 z
Minus-
cap. K cap.
okay, very good. Find the position vector of the point. Find the position vector of the point P. Point P it is defined as 1, 2, minus 3. Hmm? Position vector.
I
It is
cap,
what
J cap minus 3.
it is your position vector. That is, you can say OP. That is your I cap plus 2 J cap minus 3 A cap. Is not it?
मुझे सहगा मैडम.
Hmm? Pahala? What you are saying?
ठीक है.
Okay. Now come to the magnitude or length of the vector. The magnitude or length of the vector. A vector A, if I write down, having the component here, it is A1, A2. What is the magnitude?
Whatever you
All
want,
of
sir.
Under root A1 square plus A2 square.
Very good. So it is in 2 dimensional. Huh? And say if it is having the 3 component, A1, A2, A3. So it is your
Under root A1 square plus A2 square plus A3 square.
very good. Okay. All of you know the addition of the vector, addition, subtraction, scalar multiplication. Is it necessary to say? All of you know the 2 vector addition. It is your A vector, it is given as in 2 dimensional, say A1, A2, and vector B, if it is given as B1, B2, and C is scalar. A plus B. What do you write down? A plus B?
A1 plus B1 and A2 plus
Yes.
B2.
Already done. A1 in component. A1 plus B1. Then A2 plus B2. Similarly, A minus B. A minus B.
A1 minus B1 and A2
A1
minus
minus
B2.
B1.
C into vector A. C into vector A. I've written here C is scalar.
C A1, C A2.
Similarly, you can write down for the 3 dimensional. You can write down for the 3 dimensional or not?
Yes, ma'am.
Okay. Now do problem. If A is the vector, you may get short question here, multiple choice question here. And B is the vector. Then find A, you tell me the answer. I'll not do. Plus 5B, A minus B, then 3B. Scalar multiple, whatever. 3B. Tell me the answer. First one, what is the answer? First
Minus
one, what is
21.
Minus 2, 5, 30.
30?
21. 21.
21.
21 or 31?
31.
31. So it is the first one is over. Second one, minus 2, 5, 31. Second one,
6 minus 1 minus 2.
third one, easy.
Minus 6.
2, 1, 8.
3B, 2, 1.
Minus
It is
6,
3.
3,
3, 9.
10, 15.
5, 3, it is 15. Okay. Now, properties of vectors. Properties of vectors. If A, B, C are vectors, and D1, D2 are scalars, then first one, commutative A plus B vector is equal to B plus A vector. Okay. Then 2. A vector plus B vector plus C vector is equal to A vector plus B vector plus C. Three. If you add any null vector, A vector plus null vector, then only you get the same vector. 4. If you add the negative of the inverse vector, that is your you get 0 vector, null vector. Hello, I'm audible.
Yes, ma'am.
No net in my room now. I'm at college, but no net is now, so I'm just stopping the net. Wait, huh? Wait. Screen is visible?
No, ma'am.
Hello?
No, ma'am.
No. Screen is not visible.
No.
No, ma'am.
You
No,
haven't
ma'am.
shared yet.
No, ma'am. Not visible.
I arrange my.
Try sharing it again.
Huh?
Then please share again.
Ma'am, will you try sharing it
Okay,
again?
okay, I'm going to share again. Okay, okay. What a friends, where is the cursor? Cursor is not there. Wait, cursor is not there. What happened? पिल्ले वेट करा. Always in 2 period class I am suffering. वेट करा पिले କିଛି ଆସୁନି। Write down some question you try to do. Just all of you are listening to me. All of you are listening to me. I am audible.
Yes,
I am audible.
Yes, ma'am, audible.
Write
Yes,
down
ma'am.
some question. Do it now. I am trying my best. What happened? I know the cursor is not working here now. What I do?
मैम पूरा सिस्टम ऑफ करी पुଣି ଥରେ ଅନ୍ କରନ୍ତୁ
ହଁ
ଏମିତି
କଲ୍
ବହୁତ ଟାଇମ୍
କରି କରିଛି ବାବା କରିଛି ତଥାପି ହଉନି ଯେ ଦେଖୁଛି ଟିକେ 1 ମିନିଟ୍ ୱେଟ୍ କରି ଟିକେ ହେଲା ଏଇখানে ବଢିଆ ଲାଗୁଛି ଏ ଲେଟ୍ ହବ ବଢିଆ ଲାଗୁଛି ଏଇখানে I am audible now?
Yes, ma'am.
Audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. It is visible?
Yes, ma'am.
Yes, ma'am.
Now it is your now. Multiply by scalar, it is your D1. So we are considering two scalar D1, D2. So it is D1, D1. Having the vector, two vector like this, then what you write down? We write down it is D1, a vector plus D1, B vector. Then 6, if you add two scalar, multiply by a vector, say A, then we can write down it is our D1 plus D2, A vector. Both are the vector. Then here 7 condition, if you multiply the both scalar, D1, D2, standard basis vector. That is the vector ij in two-dimensional. It is your x, it is your y. So here this is your I cap. We say unit vector, that is we define as 1, 0 basis, and here it is j cap. unit vector, that is we define as 0, 1. The vector I and j, write down, the vector I cap and j cap and j are the standard basis of two-dimensional plane. Because it is two-dimensional, we say it is plane. And defined by I is equal to, that is your 1, 0, the component, and j is equal to, that is your 0, 1. Okay. Similarly, in the three dimensions, that is your, it is x, it is y, it is z. So it is here called as I. This is I. That is your 1, though it is three-dimensional, 1, 0, 0. It is j. That is your 0, 1, 0. And it is j. That is your 0, 0. Okay. So thus any vector V3 or R3, you say, in three-dimensional can be represented by here I, j, k, that is your I is equal to, vector is your 0, 0, 1, and j is equal to, that is your 0, 1, 0, k is equal to,
Ma'am, I
that is
equals
your
to 1, 0, 0.
sorry, how would I? Yes, 1, 0, 0, and 0, 1, 0, it is 0, 0, 1. Okay. So it is any vector. It is, if you say you have any vector, it is, for example, I am writing in general A, B, C. So that I can write down A, I, K plus B, J, K. Already done it is, plus C, A, K. That we can write down in this way. So now unit vector. What is your unit vector? Tell me.
Magnitude is 1.
Unit vector. Length is 1. So if A is a vector, what is the unit vector of A?
A vector by magnitude.
Yes, it is unit vector of A, where the vector, if vector A is not equal to 0, then the unit vector is equal to A vector by absolute value of magnitude it is. Okay. So now here come to the application part. Force is a vector or scalar?
Vector quantity.
Yes, because it has magnitude and also direction. So if several forces are acting on an object, so what do you find here? The resultant force experienced by the object is the vector sum of that force. So now by using this condition, we'll solve one problem. That is your example, that is important one. I'm going to erase this part. Here, the figure is given like this. It is your example 7. Then angle, it is 50 degree. It is 32 degree. Okay. And this is our T1 force, and it is our T2. A load with mass 100 kg. A load with mass 100 kg. The question is here. Hangs from two wires as shown in figure. Find the tension force, that is T1 and T2, in both wires and their magnitude. What will do first? First
the
we
weight.
express T1 and T2 in terms of their horizontal and vertical component. Express T1 and T2 in terms of horizontal and vertical component. It is our 50 degree. It is our 32 degree. Okay. Here the direction it is given as this way. Here direction given as this way. And when we say it is positive direction, it is negative direction. Okay. Clear to all of you? Clear to all of you?
Yes,
I
ma'am.
can do this figure again. Here there is a force here, that is resultant force. It is T1. It is T2. Here it is our 50 degree, because it is given as 50 degree. It is 32 degree. It is given as 32. So the component of T1, what is it? Sorry, T1, only T1. What is it? The component, tell me. This is I and this is J, and though it is negative side from here. Tell me.
Minus
Tell me the
T1 cos 50 degree.
Very good. Minus T1 absolute value, that is cos 50 degree IK. Is not it?
Yes, ma'am.
Is not it this one? The other component? It is positive side?
Sin
Yes,
50
plus
degree J cap.
T1 sin 50 degree J. Is not it? Okay? Say it is 1. Equation 1. Then T2. Tell me T2. It is in the positive direction.
T2 cos 32 degree I cap.
Yes, very good. T2 absolute value cos 32 degree IK plus T2 sin 32 degree J. Say equation 2. Okay. The force of the gravity acting on the load. Here, the force of the gravity acting on the load. F is equal to
980.
the gravity is 9.8. Consider. it is 100, negative side downward, so it is minus 100, that is equal to 9.8 J cap. It is our J cap. Clear? So it is, we get here 980 J cap. Okay. So the resultant force T1 plus T2 is equal to how much? It is your minus shape or not? Sorry, it is minus. It is minus here. It is minus shape. That is your 980 J. I can write down. Up to this it is clear, then after that you can do it. Up to this it is clear.
Yes, ma'am.
Okay. Now, add T1 and T2. Add equation 1 and 2. 1 and 2. So that is your T1 plus T2 is equal to, it is I am writing in terms of IK. So it is your absolute value of T1 cos 50 degree plus absolute value of T2 cos 32 degree whole into IK plus absolute value of T1 sin 50 degree plus absolute value of T2 sin 32 degree. Sin 32 degree, it is 32 degree whole multiplied by JK is equal to what we get, 0 IK, I can write down, plus 980 JK. I can write down like this. So now equating the component, what we get? What you get? Equating the component, I am writing in the next page. Next page, this one. You tell me. You are writing, you tell me what I will write down by equating the component. What will you get? Tell me. The coefficient of IK. IK coefficient are? The coefficient of IK. Tell me.
Minus T1 cos 50 degree.
Minus T1 cos 50 degree plus T2
cos 32.
32 degree is equal to 0. Is not it? I have written 0 IK. Comparing both this side, the component. So I'll get it is equal to 0. Say it is equation 3. I have written equation 1, 2, so it is 3. Then the coefficient of JK, that is your
T1 sin 50 degree. Sin
50 degree plus T2
sin
cos, sorry, sin 32 degree
is equal to